Year 12, I'm going to go over some of the questions that we did in class today. I'm going to have a go at questions 9 and 10, but I'm only going to do a couple from question 9. So let's go. 9a. I'm only going to do 9ac. So 9a is integral of sine x cos x. Now we're going to get a different answer from Margaret in the back of the book because Margaret's doing it by making that back into cos or sine squared x, which we can do, but it's why do it a more difficult way? Let's do it the way that they expected us to do in the HSC this year when it was sine squared x cos squared x, or in 2017's paper, sorry. So we're going to let u equal sine x, therefore du dx equals cos x. Remember, sine cos, sine cos, sine cos, minus minus. Therefore du equals cos x dx, and I'm going to put that in there. So what I get when I do this is I get the integral of u, because that's what sine x is, du. Oh, and that is so easy because that's u squared on 2 plus some constant, and u squared, and we'll put a half out the front rather than leaving it on, sine squared, a half sine squared x plus c. Now it's different from the back of the book, which has the answer of minus a quarter cos 2x, but it is indeed the same thing, and you could expand that and you would be able to get that. 9c is an extremely difficult one, and one that I don't think it's possible that they will ask you in the HSC. It's the integral of sine squared x cos squared x dx. Now there's a few things we have to be able to do. First of all, we need to know this law, and that is that sine, and it's written on your formula sheet or your reference sheet, sine squared x plus cos squared x equals 1, which means we can write sine squared x as 1 minus cos squared x. Okay, so we're going to get the integral. I'm going to write sine squared x as 1 minus cos squared x. I'm going to have the cos squared x outside that. And I'm going to expand that, and I'm going to get cos squared x, the integral of cos squared x minus cos to the 4x dx. Now initially that looks more complicated, but let's deal with this. Secondly, we've got to know another law, and the other one is that cos 2x, cos squared x equals, remember you should work this out, a half by using the double angle, a half 1 plus cos 2x. All right. So now we're going to split this integral up. We're going to do the integral of cos squared dx minus the integral of, watch this too, cos squared x all squared dx. Well, that's interesting. And now we'll do that substitution. So we get the integral of a half 1 plus cos 2x dx minus, well, let's write that as 1 half of 1 plus cos 2x squared dx. Okay, this first one's easy. Let's look at it. We get a half outside of 1 plus cos 2x dx minus, well, let's go in here. The half squared becomes a quarter. Now let's just look at this thing. Well, that's a perfect square. So we're going to get 1 plus 2 times each, 2 cos 2x, plus the last thing squared, cos squared 2x dx. Right, let's deal with this integration over here. This is pretty easy. We've got a half, and we're going to get x plus a half. Now what's the integral of cos again? So we'll quickly write this down. So we go sine, cos, sine, cos, sine, cos, negative, negative. The integral of cos is sine, so half sine 2x. And I'm going to leave the constant because it's going to end up being a whole constant over there. So half sine 2x. Now I'm going to take this quarter out. And I've got 1, that's easy enough to integrate, plus 2 cos 2x. And then here I've got this cos squared 2x. Now, if I look here, cos squared x, right, is a half 2 times that. So I am going to rewrite this here, just for that little bit. But my x is now going to become a 4x. So in here, I've got a half. I'm sorry, there's a plus sign there. Plus a half 1 plus cos squared. Now it's not 2x. I have to double it. And it's not squared, because that's what we're getting rid of. 4x dx. Whew. So this is all right here. So I'll expand this out. A half x plus a quarter sine 2x minus, okay, a quarter. I'm not finished with this, so I've got 1 plus 2 cos 2x plus, well, that half will go in there, plus a half plus a half cos 4x dx. Well, one more line. We get a half x plus a quarter sine 2x minus a quarter. I'm just going to tidy up. There's one other thing I'll do. I'm going to add that 1 plus a half. I'm going to get 3 on 2 plus 2 cos 2x plus a half cos 4x dx. All right, we're almost there. We're almost there. So half x plus a quarter sine 2x minus a quarter, and I'm going to put all this in brackets because I've got to do it all through. Well, that's going to be 3x on 2. Now the integral of cos is sine. I'll divide by that, so I'm going to get 2 times a half sine 2x plus a half. Well, the integral of cos is sine. I've got to divide by that, so I'm going to be timesing by a quarter sine 4x. And now I've done all the integration, I'm going to put this big plus c out the back. Okay, so here I go. I've got a half x plus a quarter sine 2x minus 3/8 x minus a quarter sine 2x minus a 32, right, 2 times 4 plus the other 4, so it's 2 times 16 sine 4x plus some constant. Now look at this. I've got plus a quarter and minus a quarter, they're going to go. And I've got a half minus 3/8. Well, that's 4/8. A half is 4/8 minus 3/8. So I'm going to get 1/8 x minus 1/32 32nd sine 4x plus some big constant. And I'm pretty sure that's the answer in the back of the book. Now, you are not, well, she factorises out a quarter. So you get a quarter x, a quarter, does she take a quarter? She takes an eighth out. Sorry, she takes an eighth out. X minus a quarter sine 4x plus some constant. And I'm going to stop now because everyone's making a lot of noise, and I'll do the other two in another video.